reviewing for your probability test, basic probability is what we're going to start with. Probability of getting a 2 out of the spinner, there's only one way to get a 2 out of 8 possible outcomes, so 1 out of 8. Probability of getting an odd, there's 4 odd numbers, so 4 out of 8, which would reduce to 1 over 2. Probability of getting a 6 or an odd, so it means I'm counting all the odd numbers, 1, 3, 5, and 7, there's 4 there, and the 6 on top of it, 5 out of 8. You could also look at the idea of an or statement, meaning adding. Probability of getting a 6 is 1 out of 8, probability of getting an odd is 4 out of 8. Probability of getting a multiple 2 or a multiple of 3. So with that one, if you try doing the addition, well, the multiples of 2 would be 2, 4, 6, and 8, so that would be 4 out of 8. Probability of getting a multiple of 3 would be 3 and 6, so that's 2 out of 8. The issue with that, though, is that you've got too many, because 2 has a multiple that gives you 6, 3 also has a multiple that gives you 6. So really you only got 2, 3, 4, 6, and 8. So really you only have 5 out of 8. So the way you get that is you have the 4 out of 8 for multiples of 2, 3 out of 8 for multiples of 3, but you need to take away that 1 overlapping. So the probability of each minus the overlap probability. So you can do it with the sum or individually. Probability of getting a 9, there are no 9s, so that probability is 0. And here's a given. You're going to have a bunch of these spaced out through your test. Probability of getting a prime number given that it's odd. Well, your only odd numbers are 1, 3, 5, and 7. So you only have 4 options then, because we know it's odd. And probability of that being a prime, well, 1 is not prime, 3, 5, and 7 all are. So 3 out of 4 is your probability there. Next page, we got 2 dice being rolled. What's the probability that both land on a cube? So on a 2. So that means 1 out of 6 is your probability that the white one lands on a 2, and 1 out of 6 is that the blue one lands on a 2. So you multiply because you said the word and. White cube and blue cube, so 1 out of 36. Probability that the white cube is an odd and the blue number is bigger than 4. So odd, well, there's 3 options out of 6 times bigger than 4. That means only 5 or 6. So that's 2 out of 6 options. So you'll multiply and simplify, and you would get 6 out of 36 when you multiply across, which reduces to 1 out of 6. Probability that the blue cube is bigger than the white cube in terms of its value. Well, here's how I'm going to look at this. Something like this, I'm going to list out the different outcomes. I'd have 1, 2, 3, 4, 5, and 6 for the different options for the white cube. The blue cube, obviously, can also be 1 through 6. If the white cube comes out 1, we want to know when the blue cube is bigger. So 5 different numbers on the blue cube would work for that. If the white's a 2, that means 4 different numbers would work for the blue cube. So on and so forth. This could be 4, 5, or 6. This could be 5 or 6. This could be just 6. And no options will work for that. So total number of outcomes, I would just add these guys up. I'm going to get 15 different possibilities. So 15 is your total possibilities out of there's 36 total outcomes when you roll the dice. And that's because you have 6 choices for each 6 times 6. The probability that the white cube is odd and the blue cube is even. White cube is odd would be 1 out of 2 because you got 3 out of 6. And blue cube being even is the exact same, 1 out of 2, multiplying to get your 1 out of 4. What's the probability that the sum of the 2 cubes is at least 9, meaning 9 or more? Well, I'm going to list out options again, kind of like I did over here with the last problem. So 1, 2, 3, 4, 5, and 6. If the first cube is a 1, then no matter what, I'm not going to be able to add up to 9. Second cube is a 2, I still can't add up to 9. I can't get to 9 until I have a 3. 3 will only work with a 6, so only one option will work here. 4, I would need to have either a 5 or a 6, so 2 different options there. The first one's a 5, I could have a 4, 5, or 6, so 3 options there, and a 6 with a 4. So I have here a total of 10 things that will work out of 36. And actually I can reduce both of these fractions from those problems. That becomes 5 out of 9, and this one I can divide by 2 and get 5 out of 18. So actually it's twice as more likely for number 9 to happen than number 11. And number 12, the probability that the blue cube is larger given that the white cube is a 4. So if I'm given that the white cube is a 4 already, That means the only things that are going to work are 5 and 6. So I only have 2 options that'll work, and I already know what this cube is, so it has no bearing at all on the problem. 2 out of my 6 options for that blue cube, so 1 out of 3 would be your answer. All right, next one, we have the deck of cards. It's telling you all the information about the deck of cards. Probability to get a 2, well, here's your picture of the cards. There's 4 2s out of 54, or 54, wow, 52. Or you can look at it, there's 1 2 for each of the set of each of the suits, and there's 13 in each suit. Either way, it reduces to that same fraction. Probability of getting a red card, well, that's the 2 suits out of 4. That's 26 cards out of the 52. So you have a 50-50 chance, 1 out of 2, of getting a red card. Queen or king, well, I got 2, 4, 6, 8 queens and kings out of 52. Or I can look, I got 2 out of each suit, 2 out of 13. That's what that fraction reduces to. To be a jack and a diamond, here are my jacks, here are my diamonds. The only one that's both is this guy right here, so 1 out of 52. Jack or a diamond, so that's where you're thinking adding. So for adding jack or diamond, you got 13 diamonds out of the 52. You have 4 jacks out of the 52. However, this guy being the jack of diamonds, that's the jack and diamond that you're double counting. So you need to take that guy back out. So when you add those up, you get 16 out of 52, which can reduce to be 4 out of 13. You could also have just added 1, 2, 3, all 13 here, 14, 15, 16. Make sure you're not counting that jack the second time. Now, with face cards here. Face card has a face on it, jacks, queens, and kings. So the probability of getting a face card, there's 12 out of the total 52 that have a jack, queen, or king, and that would reduce to the 3 for each suit, 3 out of 13. To be a face card and a spade, so that's these guys right here. There's just 3 of them, so 3 out of 52, that cannot reduce. The other way to look at it, a face card we said was 12 out of 52. The probability of being a spade was 13 out of 52. Each of those fractions could have reduced to be 3 out of 13 and 1 out of 4. And when you multiply that across, you would get 3 out of 52, the exact same thing. And that works because those are exclusive AND statements. Now, the probability of being a king, given that it's a face card. So, if I know that it's a face card, meaning it's just one of these 12, what's the probability of it being a king? There's only 4 kings out of the 12 cards that I know. So you have a 1 in 3 chance of getting a king if I tell you it's a face card. Now, the other way around, what's the probability of it being a face card if it's a king? Well, all kings are face cards. So if it's a king, I know it's a face card. So that's a probability of 1. It's a 100% guarantee. The next section here deals with probability in pulling marbles or something out of a bag. So the first one, what's the probability of drawing a striped marble? There are 3 striped marbles out of a total of 10 in the entire bag. So that's just your probability. Now, 22, what's the probability of drawing a striped marble, putting it back, and drawing another striped marble? So multiplications are key because of and. Drawing a striped marble, we just said was 3 out of 10. Then when you put it back in and draw again, it's still 3 out of 10. So you multiply those and get 9 out of 100. Now 23 is the same idea, but you're not putting it back this time, drawing a striped marble both times. So 3 out of 10 is still for the first time. Now it's like that marble is gone. So there's only 2 marbles left out of 9 remaining in the bag. So 6 out of 90 is your probability, which would reduce to be 1 out of 15. That's your probability. Next one. Now you're drawing a black marble, putting it back in, and drawing it again. So let's get rid of that. So all marbles are back in there. So you got 1 black marble out of 10, and drawing another black marble. So 1 out of 10 again. So 1 out of 100 is that probability. For 25, same idea now, but we're not replacing it. So 1 out of 10, then that black marble is gone. Well, there's no black marbles left. So the probability of getting a black marble twice in a row if you're not putting it back is impossible. There's not a single chance at all. Next set, dealing with tables, we have a lot dealing with the conditional probabilities here, probability of A given B, that sort of thing. 26, probability that you get a black number when it comes up on the roulette table. Well, the black is right here. You have 18 total black spots out of 38. So 18 out of 38, which can reduce to 9 out of 19. 27, the probability that it's a red, given that it was an even number. So here's all the evens. There's 18 evens on the board. What's the probability that it's a red? Well, that's 8 out of 18, which would be 4 out of 9. Probability that it's red, given that it's not even. Well, not even means that it's either odd or 0. So there are 20 total guys that are odd or 0, only 10 of which are red. So it's a 50-50 chance, 1 out of 2, that you get a red if I'm telling you that it's not even. And last one, probability that it's green, given that it's 0. Well, here's the zeros. Well, of the 2 zeros on the board, they're both green. So that's 2 out of 2, which is just a probability of 1. If I tell you it's a 0, I guarantee it will be green in color. All right, the last one's random probability questions that you have to answer. So the first one, you're rolling a number cube, flipping a coin, and spinning a spinner from the first page. What's the probability that you roll a 3, the coin lands on heads, and the spinner lands on a multiple of 3? So we'll go one at a time. Probability that you roll a 3 is 1 out of 6. There's only 1 3 on the dice. Probability that the coin lands on heads is 1 out of 2. And the multiples of 3 were just 3 and 6. So that's 2 out of 8 or 1 out of 4. And is the key. You're going to multiply all of those numbers and you're going to get 1 out of 48 for your probability. The next one, you're flipping a penny, a nickel, and a quarter. What's the probability that exactly 2 of them land on tails? Well, each one of these has two outcomes. So 2 times 2 times 2 gives you 8 total outcomes. We want exactly 2 of them to land on tails. So that means of the 3 coins, 2 of them should land on tails. That would be your answer, and that's fine just like that. If you want to simplify it out, it would be 3 over 8. Now another way, the hint says you could list all the outcomes. Well, if I had the penny, the nickel, and the quarter, well, they could all be heads. The first 2 could both be heads, but the quarter can change to tails. Penny can be heads, but now let's say the nickel is tails. Well, here's 2 more options. Well, then I can keep going. I can say all these options again, but now let's say if the penny was tails. So these guys being both heads. Now the quarter's tails. Now the nickel is tails. And now they're all tails. They want to know how many of those have exactly 2 heads pop up. So there's 1 there. We change the color. There's 1. There's 1. And there's 1. So you have 3 outcomes out of the 8. So a couple of different ways that you could have looked at doing that problem. 32, the probability that you qualify for states is 20%. The probability you get a medal is, and qualify for states, is 5%. What's the probability that you medaled given that you qualified for states? So what this is the conditional probability. Probability that you medaled given that you qualified for states. Well, the way you do that, the formula is the probability that both happened, you medaled and went to states, divided by the probability of your given, the probability that you made it to states. And we know both of those. They gave them to us. Probability you qualified for states is 20%, 0.20. The probability that you medaled and qualified for states is 0.05. So you're just going to do that division, 0.05 divided by 0.20, and you should get 0.25, or 1 out of 4, as that probability. That's just as simple as knowing what the formula is. All right, 33. The letters and dots, and they're placed in a box and drawn one at a time. What's the probability that they are drawn without replacement, and you draw them in the correct order to spell that word? So, what you got to do. The first one you got to draw must be the letter D. Well, there's only 1 D out of the 6 in the bag. And now I need to pick the letter O. There's 2 O's in the bag, and now there's only 5 remaining, so 2 out of 5. Next, the T. There's only 1 T out of 4 remaining. Then the S. There's only 1 S out of 3 remaining. Then the O. There's only 1 O remaining out of 2. And then, picking the N last, there's only 1 out of the 1 left. That is the N. So there's your fraction. You're saying and, so you got to multiply all that. You get 2 out of 720. which is 1 out of 360. So not great probability of that happening. Now the next one says, what if each time you put the letter back? So it still starts that you have 1 out of 6 chance of drawing the letter D to begin with. Well then, next you still have 2 O's, but now there's 6 still in the bag because you're putting all of them back. There's still 1 T and 1 S out of 6 in the bag. There's still 2 O's now because you're putting them back each time, and then 1 N out of the 6. So you're going to get 4 out of 6 to the 6th power, whatever that ends up being. It ends up simplifying down to being 1 out of 11,664. You could leave it just like that, as far as I'm concerned. 35. An exam has 10 questions, 4 choices each. You want to know the probability that you get exactly 6 of the questions correct, and therefore you pass. Well, here's how it's going to look. Each question has 4 possible answers. And there are 10 questions. So 4 to the 10th power is the number of different ways that you can answer each question. We need to have, of the 10 questions, get exactly 6 of them correct. That's your answer, leaving it exactly like that. 10 choose 6 over 4 to the 10th. If you want it as a fraction, it's 105 out of like 524,000. So not exactly great odds just by guessing. And that's, again, if you get exactly 6. It's obviously much better chance if you need to get at least 6. If it was at least, just for fun, you'd have to look at, okay, I could get 10 out of 6, I can get 6 right, I can get 7 right, I can get 8 right, 9 right, all 10 right. That's how you would do it if it was at least 6 instead of exactly 6. All right, 36. You roll a 4-sided die and a 6-sided die. What's the probability that the 4-sided die has a number that's bigger than the 6-sided die? Well, your 4-sided die can only be 1, 2, 3, or 4. I need to make it so that this is the bigger number. So, for the second die, well, no numbers are going to work so that this first table is better. If I roll a 2, well, only a 1 is going to work. If I roll a 3, only a 1 or a 2 is going to work on the other one. So I got 2 choices. If I roll a 4 on the first guy, then it can be a 1, 2, or a 3. So these are the number of ways that it will end up working. So 6 total ways will work. The number of total possibilities, I had 4 choices for the first guy, 6 for the second guy. So it's 6 out of 24, which would reduce to 1 out of 4. So I have a 1 out of 4 chance of that happening. Last 2, letters in mathematics are put into a hat. What's the probability that you randomly draw an M, given that the letter you draw is a consonant? So this is like a game show. You pull a letter out of a hat, they tell you it's a consonant. They want to know if you think it's going to be an M or not. Well, you know it's a consonant. So how many consonants are there in this word? Looks like there are 7 of them. So of the 7 consonants, how many of them are the letter M? 2. That's your answer. That's all you have to do. If they wanted just for another one, if they said vowels, let's say probability that it's an A given it's a vowel. Well, there's 4 vowels, 1, 2, 3, 4, and 2 of them are A. So you have a 50-50 chance if they tell you it's a vowel that it would have been the letter A. And last one, probability of winning the Powerball is about the same as flipping a coin and having it land on heads 21 times in a row. What is that probability? Well, you flip on a coin, get a head. You have a 1 out of 2 chance. Flip it again, get heads again, 1 out of 2. 1 out of 2, over and over and over again, 21 times. When you multiply those, it would be 1 on top, 2 to the 21st power on the bottom. So that's your probability. If you wanted to multiply it out, it's over 2 million. That's about the odds you have of ever winning the Powerball at any given time. Not very good odds, 1 in over 2 million. There you have it. Best of luck, and may the odds be ever in your favor.